Okay, we're going to be looking into equations with non-integer exponents. And going back to our properties of exponents, again, we have between radicals and exponential expressions that are raised to fractional powers. Again, we have a to the m over n is rewritable in terms of a radical where we have the nth root of a to the m. So these expressions are one and the same. Right. Now, for equations that are expressed in terms of non-integer exponents, we're going to rewrite in terms of radicals. Now, we have for the first case, we have x to the 1/2 is equal to 3. So we have a non-integer exponent with m over n at 1/2 and writing as a radical. Okay, so we have the nth root of a to the m, and we're going to take what we have here. So n is represented by 2, and you have x is to the first. So we have the square root of x is equal to 3, so we have an even root. 3 is a non-negative value, and we can proceed on the basis that we do not have violation of the principal square root rule, which states that an even root of an expression cannot reduce to a negative value. And so looking at getting rid of the square root and freeing up x, I'm going to square both sides of the equation. So we have the square root of x squared. This will go to x, and for 3 squared, okay, that is going to come out to 9. Thus, we have 9 to the 1/2 is equal to 3. For the second case, we have 2x plus 1 quantity raised to the 1/3 degree is equal to 3. And rewriting this expression in terms of a radical, so we're going to have the cubic root of 2x plus 1 is equal to 3. And so taking what we have now, okay, so you have the cubic root of 2x plus 1 is equal to 3, and taking on both sides so as to eliminate the index number 3, I have the cubic root, and to get rid of cubic roots, I'm going to cube both sides. So we have, in this particular case, all right, so we have the cubic root of 2x plus 1 raised to the 3rd. So this is going to go to 2x plus 1 and for 3, I'm going to take that to the 3rd power. 3 cubed is 27. And we have with 2x plus 1 equal to 27. So I'm going to take away 1. And I have 2x is equal to 26. And with division by 2, okay, 2 will go into 26 13 times. Now, in taking what we have here, so we're going to have the cubic root of 2x plus 1, or where we have x at 13, so you have 2 times 13 is 26 plus 1 is 27. To the 1/3 comes out to 3. All right. Now, for what we have in the case of the third item, so we have x to the 3/2 is equal to 8. And if I rewrite what I have here, so I have x to the 3/2, so I'm going back to square root expressions. So I have the square root of x cubed is equal to 8. And then to free up x cubed from the radical, so I'm going to square both sides of the equation. And for what we have in this particular instance, I'm sorry for this jumping around. So looking at squaring both sides, okay, so we have x cubed squared, or the square root of x cubed squared, so we'll have x to the 3rd. 8 squared is 64. And now, to get rid of the cube for x cubed to express in terms of x, I'm going to take the cubic root of both sides And so for the cubic root of x to the third, okay, the exponent is eliminated by the index number of the radical. So we have x, and we have with the cubic root of 64, that is going to go to 4. So we have that 4 to the 3 halves is equal to 8. Now, for what we have in the fourth case, we have the quantity of x plus 1 raised to the 2/3 is equal to 4. So 3 defines the type of radical we have. So we have the cubic root, and we have x plus 1 quantity squared is equal to 4. And to get rid of the radical, I'm going to take both sides and raise to the third power all right, so I'm going to have the square of x plus 1 is equal to 64. Now, we have the square of x plus 1. If I go from the square of x plus 1 to first order, I'm going to take the square root property of equality. And once again, we have the square root property of equality. Okay, so again, if we have the x squared is equal to p, then x goes to plus or minus the square root of p. And for what we have in this instance, okay, so we have x plus 1 is equal to plus or minus the square root of 64. Square root of 64 is going to be 8. So we're going to have a couple of solutions for x. One is going to be where we have x plus 1 is equal to -8. And for what we have at the upper end, we have x plus 1 is equal to +8. And looking at taking away 1 from both sides of both equations, we have for x plus 1 is equal to -8, x comes out to -9. And for x plus 1 equal to 8, we have that x is equal to 7. So x is going to have two values that will be workable in the original equation. So regardless of whether it's -9 or 7, it is going to fit into the equation where we have the quantity of x plus 1 raised to the 2/3 is equal to 4. All right, now we have with 2 times the quantity of x plus 5 raised to the 2/3 is equal to 18. And so for taking what we have now, if I divide both sides of the equation by 2, all right, so we have in the reduction, so we have with division by 2, so we're going to have x plus 5 quantity to the 2/3 is equal to 18 halves, which is 9. So we have, putting in terms of a radical, this is going to go to the cubic root of x plus 5 quantity squared is equal to 9. And removing the radical, we have upon cubing both sides, so left-hand side becomes the square of x plus 5. And the right-hand side, we have 9 cubed comes out to 729. And once again, utilizing the square root property of equality, we have x plus 5 is equal to plus or minus the square root of 729. So we have x plus 5 is equal to plus or minus 27. So we're going to have two solutions for x. So we have at the lower end, we have x plus 5 is equal to -27. And at the upper, we have that x plus 5 is equal to 27. And taking away 5 from both sides of both equations, for x plus 5 is equal to -27. -27 minus 5 is going to be the lower x value, which will become -32. And for the higher x value, take away 5, and 27 minus 5 comes out to 22. So we have two solutions again in x, whereupon we have on the minus side we have -32, and on the plus side we have 22.